Okay, in this lesson, we're going to talk about the drawing of vector diagrams using the tip to tail method. This is actually the first of the many lessons that I'm going to conduct on the drawing. The purpose of this lesson is because when students come to the actual drawing of tip to tail, they falter because the actual drawing requires a little bit more skill. So I'm going to show you step by step how to do it. Now, first of all, here are the steps that I will recommend. The first thing is that you really have to write down and select the appropriate scale. This followed by drawing a reference line. What do I mean by this reference line? The reference line is only if it's needed, and the reference line is usually either the horizontal or the vertical line. Alright, so I'll explain this later. Then subsequently you will construct the first line or the first force, followed by the construction of the second force using the tip to tail method. Okay, then if you want to find the resultant force, you will just have to join the starting and the ending point of the two lines. And then to find the value of the resultant force or the magnitude, you just have to connect the starting point and the ending point, and to measure and convert the value of the resultant force. And finally, you will also measure and express the direction. Okay, so to kick off this finding of the resultant force using vector diagram, I will use this question, which is a very basic question, to start first. So you might want to pause the video and just write down the question so that you may want to join in to do the construction. So first of all, is this question where the 5 Newton and 10 Newton force is separated by a right angle, okay, of 90 degrees. So how do you find the resultant force? First of all, just to let you know, usually the space that you're required to draw a resultant force is roughly half of an A4 size paper, because the question is usually such that there will be some information or the diagram of the vector diagram above and some questions below. So in normal exam situation, the area used to draw the vector diagram is about half of the A4 size. So I use the typical size to draw, because you need to know that your vector diagram needs to occupy as much of this space as possible so as to be accurate. If your vector diagram is too small, you will be penalized. Okay, so let's start. So if this is a 5 Newton and a 10 Newton force, okay, one easy representation is 1 cm to 1 Newton. So a 10 Newton force will be about this length, and a 5 Newton force will be about this length. Okay, so basically I will say that this scale of which I'm going to select, alright, this scale of 1 cm to 1 Newton is a very suitable scale. So I'm going to pick this scale. Then first of all, we draw the first force. I will select the 10 Newton force to draw. So let's start with the 10 Newton force. So first of all, you mark out the length of a 10 cm, which represent the 10 Newton force, and then you draw the line. Okay, use an arrow at the end of the line to represent the end of the 10 Newton force. So this line will represent your 10 Newton force. So next, okay, you need to draw your second force, which is your 5 Newton force, in a tip to tail fashion. Let's look at the question again. So what happens is that this 5 Newton force will go here in order to complete the tip to tail. So basically we are already at this point. We have skipped the drawing or reference line because this one doesn't need one, as the 10 Newton force and the 5 Newton force is already on the horizontal and vertical. So we construct the first line, and then we construct the second line using the tip to tail method. So the second line will be 90 degrees from the 10 Newton force. Okay, which I will mark out the 90 degrees now. Then after that, I will draw the 5 cm to represent the 5 Newton. So after this, the next step will obviously be to find the resultant force by connecting the starting point and the ending point. Okay, so this will be your resultant force, and usually we put 2 arrows to indicate resultant force. Okay, you must remember 2 arrows to indicate resultant force, 1 arrow for the 2 forces, and you need to label this. This is a 10 Newton force, this is a 5 Newton force, this is right angle, and this is your resultant force. So we have joined the starting point and ending point, so we need to measure and convert the resultant force to find the resultant force, as well as to measure and express the direction. So how do you find the resultant force? So after I measure this, the value shows me to be 11.3 cm. So 11.3 cm is actually 11.3 Newton, right? This cm, because it's a 1-to-1 conversion. So in other words, your resultant force, okay, to present it nicely, the magnitude will be 11.3 Newton. Now how to find the angle? You find the angle between the resultant force and the closest angle, sorry, the closest force to the resultant force. So in this case, we get 27 degrees. But how do we express the direction of the resultant force at all? So in order to express the direction of resultant force, we have to consider a reference force. In this case, the reference force is the 10 Newton force. Now what happens is that the resultant force and the 10 Newton force is 27 degrees apart. So how does the 10 Newton force change its direction to a resultant force? It has to rotate in this direction. In order to rotate in this direction, it is rotating in which direction? Anti-clockwise. So from here to here is anti-clockwise, from here to here is clockwise. So obviously it's rotating anti-clockwise. So if it's rotating anti-clockwise, you can express the direction as 27 degrees anti-clockwise from the reference force, which is, and then from the 10 Newton, and then you get your solution. So this is how you do vector addition. Okay, there will be some more videos coming up on more difficult cases. Alright, so please go to the next video for the next more challenging case. Thank you.